So looking at worksheet 3, we graphed a couple of them, number 8, number 9. Again, just be careful with the negative angles, negative, it's a lot to keep up with. It's not hard, just be careful. And then we converted each of them with those equations that you have to know. So this isn't bad, you people that are sitting in class with me now, that you hear me say it one more time. X equals r cosine theta, y equals r sine theta. But that, again, those continue to go together. Cosine goes with x, sine goes with y. It was true on the unit circle, it was true with parametric, and it's true now that we're converting polar and rectangular. So hopefully we've seen those two tied together enough that it doesn't throw you off. On to the back. More conversions. So a conversion in the 11 through 18. Which one? You got a preference? 12 and 13. 12 and 14. Let's see. So the other equations are x squared plus y squared equals r squared. And the other one is tangent of theta equals y over x. But sometimes you can tell by looking what the angle is. So usually the angle, if you graph it carefully, you can tell by looking. So you don't have to graph it, but I think it makes it easy if you do graph it. Let's see, 0, negative 6. 0, negative 6. That would be right there. Now, forget the equations. If you graph 0, negative 6, I hope you can give r and theta just by looking at it. The theta is 3 pi over 2, and the r is 6. So for a lot of these, it's like, do you need the equations? I mean, technically, but a lot of times you can just look at it and figure it out. I think I'll leave that one as just a look at it and figure it out problem, because on 14 we probably will need to use the equations. Although still not a bad idea to graph it. Negative root 5 comma root 5. Okay, well I don't know what square root of 5 is, but they're equal to each other. So however much back I go is how much up I will go. And you know what? I think I know what the angle is. Square root of 5, square root of 5. So r squared, again, even if you don't remember the formula, you can remember the formula by looking at the picture. Square root of 5 squared plus square root of 5 squared. So 5 plus 5 is 10. So r is the square root of 10.
The key has that formula. It squares the funds. So it's like 25 plus 50.
Oh, it has square root of 50 then? Yeah. Okay, so apparently the key is wrong on this one. I apologize for that. The angle, well, I can do the tangent thing, but I can also just look at it. It's in the middle of the second quadrant. So what angle is that? Ty? 2 over 2. What angle is it? So it's going to have a pi in it. Let's see. The middle angles are the over 4s. So 3 pi over 4. So square root of 10, comma, 3 pi over 4. These equations, I don't want to say they're less important, but sometimes you can get away without having them memorized because you can kind of figure them out if you draw the picture. Let's do some of the equations down here because sometimes those get a little bit crazy. Number 19, 2x squared plus 2y squared equals 50. I need to remember what those x equals r cosine theta, y equals r sine theta. and x squared plus y squared equals r squared. Whoa, this looks like x squared plus y squared. If I'll divide everybody by 2, so r squared equals 25, r equals 5, and then it said graph the resulting polar equation. We didn't graph any of those yesterday, so this part is a little bit new. If I want to graph r equals 5, so I need the radius to be 5, and I don't care what the angle is. So I'm going to go out 5, 1, 2, 3, 4, 5. But it doesn't matter what the angle is, r is 5. And it makes, I hope, what you think it would make. If r equals 5, that sounds like the description of a circle with radius 5. It's also a circle from rectangular coordinates. So either way, it's a circle. Number 20. Write the equation r equals 8 sine theta in rectangular form and graph the resulting equation. Okay, so I'm trying to match up polar stuff to rectangular stuff, and it's not quite a match. There's a trick we could do to make it be a match. You see what the trick would be? I think we did it yesterday. It'd be nice if this was r sine theta. So if I multiply both sides by r, so let's see, x squared plus y squared equals 8y. Now, we did not make it this far yesterday. X squared plus y squared minus 8y, leave some space, equals 0. This is not your favorite thing to do in a math class, but if I leave a blank right there, any idea what we're going to do? There it is, complete the square. Half it, square it, add it. So b over 2 is negative 4. If we square that, we get 16. So we'll add 16 to both sides. X squared plus y minus 4 squared equals 16. So that's a circle at 0, 4 with radius 4. Ooh, first circle of the day, a little bit rough. That sort of leads into what we're going to do today. So let's stop there. Number 22 is really similar. Multiply both sides by r, and you get there. 21 is a little bit tricky. I wouldn't worry about 21. And again, 20 leads into what we're going to do today. So let's pause there.